And good evening, everyone. Welcome to tonight's live chat. It's good to see everyone here. We're already starting to see people come into the room, and we're seeing people coming in on YouTube, so that's good to see. So, we have a lot to talk about tonight, a lot of things that we're going to be covering. Of course, I got the Mets over here. Keep an eye on that. And I got a lot of data to share with you here. We issued the summer forecast and the tropical forecast on Sunday night, Monday morning, depending on when you get back online. I know a lot of people like to stay offline during the weekend, which is understandable. So the summer forecast is out, tropical forecast is out, and we also have a very interesting system that's starting to develop for this weekend, for Saturday, that has the potential of producing some heavier rainfall for the region. And I drew some diagrams here. We'll talk about that as well, as far as what to expect with the system. First and foremost, though, I want to share some observations. This right here is smoke from a forest fire in Canada. And basically we have this nice northwesterly flow in place of transporting very nice, comfortable air, but it's also transporting smoke. Now, what's going to be interesting to see is how much does this smoke help to insulate the region a little bit. Excuse me. The reason why that is a question is because tonight we'll have the potential, especially around the Poconos and Catskills, of temperatures really falling off to around 33, 34 degrees. That could cause some serious damage to some vegetation out there. So definitely protect your vegetation out there because it is going to get rather chilly tonight. But the question is whether some of that smoke might insulate us and get us more up towards 35 and 36 and protect us from the worst case scenarios here in terms of the impacts of colder air on the region. So, well, the Mets are already losing. Oh well. Well, they got to the fourth inning. What can you do? So let's talk about the evolution of our pattern here. And what I want to do is start off with the sea surface temperatures. Okay, it's pretty clear what's evolving here with El Nino taking hold. We've been talking about for the past couple of weeks, and it's clearly starting to take shape here. It is expanding into Nino 3.4. and likely to continue to expand. The more I'm looking at this El Nino, as far as the observations, the more I'm thinking that this is a basin-wide El Nino event. It's not going to be focused more towards the east or to the west, but basin-wide, and it's going to have widespread influences. Another thing that is becoming clear is that this... Oh, okay, your headphones aren't working. All right, the other thing that is pretty clear here with our above normal temperatures is that it's more likely to be a strong El Nino. Now, what does that mean? What are we going to be watching out for? All right, well, yes, temperature-wise, there's a pretty strong support for this becoming a strong El Nino in terms of getting our sea surface temperatures above 1.5 degrees Celsius above normal. But what's important to me is the SOI values. Now, much like La Nina, the reason why we watch this is because this has a far more direct impact as far as what's going on in the atmosphere. So when I start seeing an SOI value in the seasonal 90-day and monthly 30-day averages, is when I start to see negative values around minus 15, minus 20, that is a moderate to strong El Nino. If we stay below minus 15, then the atmosphere responds more like a weak to moderate El Nino. So that's very important to watch because a lot of people automatically connect sea surface temperatures to the strength of the El Nino or La Nina event. And I think that is a mistake. You want to use a combination of both the temperature anomalies and also the SOI anomalies, because then you get a full, complete picture of the actual circulation of the El Nino event. So we're going to be watching this very carefully to see how this evolves. You can see the daily contribution here has been steadily negative since May 9th. And of course, that matches up very nicely to the MJO shift going from phase 5 to phase 6 and heading into phase 7. So when we're into phase 6 and phase 7, we start to support more of an El Nino circulation. And if some of the long range data is correct, where we get into phase 8 and potentially into phase 1, that's really going to rocket and enhance this El Nino development. And I think that we'll have an official designation of a full El Nino effect by the time we get to the middle of June. So what does that mean for the overall pattern? Well, there's one other thing that we should check, but I also want to show you this before we get to there. This is the convection. When El Nino starts to develop, and you can start to see it right here, you start to see more convection really starting to fire around the date line. The more that we see convection fire around the date line, the more that these storms up here are going to start to get enhanced, and the more the subtropical jet stream is going to start to get enhanced. The deeper the troughs will get around the Aleutians, and the deeper the troughs will get around eastern North America. So we're seeing that process beginning. And while that process is beginning, we're also starting to see, as a result, changes in the Northern Pacific, where we had just 2 weeks ago a robust negative PDO signal that has rapidly started to fade and collapse. Most likely will be in a positive PDO state, I would say by July. So what that essentially does is that it supports a feedback process of the El Nino influence on the entire 500 millibar pattern. But there's one other thing that really catches my eye, and that is the stratosphere. Now, premium members, I talk about the current state of the stratosphere right now and what it means for our weather pattern as it stands right now. But something really stands out to me when we get beyond 5 days. And I've been seeing this constantly in the 50 millibar stratospheric temperature anomalies. Hasn't gotten below 5 days yet, but it's a signal that kind of has my attention. And that is this signal right here. Just a little warm pocket. It keeps on showing up once you get beyond 5 days in the forecast. And beforehand, it was a little bit unrealistic. Now the forecast is getting a little bit more realistic. And the reason why this really stands out to me and why it's important to me is that when you have a cold stratospheric environment, okay, the stratosphere cannot expand out or sink into the troposphere or expand out into space. So what happens is that when it gets cold, it shrinks and it allows the troposphere to expand. When you have a warm stratosphere, it expands but presses down. It doesn't press out into space. So when it presses down, it leads to lower 500 millibar heights at the troposphere where we live. And the reason why this kind of stands out to me is that if this signal verifies at some point during the summer, you would set up an upper level low somewhere around the Tennessee River Valley. Meanwhile, you have this cold signal that keeps on showing up over the Western Atlantic. This would support an environment where you can get a Western Atlantic ridge going, you get a tropical low hanging around here, an upper level low here, trouble for the mid-Atlantic. Now, that doesn't mean a hurricane, okay? I'm not forecasting telling you that, hey, look, there's going to be a hurricane on the way. What I'm saying is that if we continue to see this signal, and it actually gets below 5 days in these stratospheric anomalies, it opens up the threat for taking tropical moisture and driving it right up the coast. And why I'm concerned about that is that a lot of times this year, you're going to have a dry weather pattern like we are right now. And the topsoil is going to start to get hard. Then you throw in a random heavy rainfall event with some tropical influence, and you're going to get a lot of wash off of the topsoil, which is really bad for farmers, and it opens up the threat for flash flooding because our water table isn't able to rapidly handle all this rainfall all at once. So as far as our calculations and how much rain we get, yeah, we rebound to near normal, but most of that rain doesn't get into the water table. It just washes right off into our drains and produces a threat for flash flooding, but doesn't actually reduce the impacts of a potential drought that might start to show up if we continue on with these dry conditions. So this signal keeps on standing out. Then when we take a look at the 500 millibar pattern, and again, we have our El Nino influence starting to take shape, and you can continue to see in various models this idea of a weakness on the East Coast and a weakness around the Canadian Maritimes. And it's showing up in various forms on a variety of models. You could use the European, the GFS, the European ensembles. You're not looking for the same type of pattern, okay? You're not looking for a 100% match. What you're looking for is a general theme. And I see this general theme of a continuation of a trough axis on the East Coast, somewhere between the Great Lakes and the Canadian Maritimes. So this would suggest plenty of cold fronts moving through. Watch out for your mesoscale convective system, i.e. very strong storm complexes coming out of the Great Lakes, dropping in towards our neck of the woods. But another thing that stands out is what I'm seeing here in the long range model guidance. It's showing up here for July, for August, September, and October. What does this mean for us? Well, again, we take the stratospheric data. Then we take some of the climate data that we're seeing here. And again, you don't take this verbatim, but what do you constantly see? This trough hanging around the Tennessee River Valley, this ridge hanging around the Western Atlantic. You can get a tropical system that kind of spins up here, and then watch out. So this is why I said in the tropical forecast, and I've been saying for years, yes, this is likely to be a relatively quiet season, especially compared to what we've been seeing over the past couple of years. But it only takes one. And this signal is a warning sign. So personally, we're getting prepared just in case, because all you need is one tropical system, one hurricane, and you can end up with a 10-inch rainfall event hanging around your region and some significant problems, okay? So we're watching that very, very carefully as far as the long range. And I'm going to take all your questions based on this. Now, there's a couple other factors with this type of cold environment overall in the stratosphere. It opens up the potential for very intense heavy downpours and very intense thunderstorm development. Because the stratosphere is cold, the troposphere is warm, so you have a rapid rising parcel in the atmosphere. And what that basically means is that your thunderstorms are able to grow larger and become more intense. So that rapid rising in the atmosphere, what that does is that it supports the potential for thunderstorms to feature not only heavy downpours, but hail, frequent lightning, strong downburst wind gusts, and yes, potentially more tornadoes. So a lot of interesting signals. Then we have this weekend. This weekend, at the surface, you would say, well, it could be a nice little heavy rainfall event. But why is this system really catching my eye? Well, because there is a small signal of a warm core low. And I want to show you something that I drew here. 1 minute. Okay. Now, you know I was going to use this sooner or later. I hope you guys can see this okay. Good. Let me get on this side here. Okay. All right, good. Now, what I have here, and again, this is a work in progress, so I know it's not the best drawing, but I think I did New Jersey pretty well here. We're having somewhat of a warm core low trying to develop off the East Coast by the time we get to Saturday morning. Right around, I would say, North Carolina. It's this little designation right here. What's interesting about this warm core low is that at the highest it gets in the atmosphere is about 850 millibars. So this is a weak warm core low. It's not a strong warm core low. It's a very disorganized low. But why is it important? Because of how it draws moisture, tropical moisture, on the northern and western side of the circulation as it's starting to develop. And while it's starting to develop, we have these upper level winds. These upper level winds are from the trough that is approaching us. So that deep moisture basically is drawn northward into the New Jersey coastal waters and then through Long Island by the time we get to Saturday afternoon, evening. And because of the type of structure we have here, what you end up with is a very tight gradient of moisture that focuses on the coast and leads to a heavy rainfall event. So how does that look in the model data? Well, let me show you. I'll pull this up. At 90 hours out, actually let's go to 84 hours out. This short wave is the short wave that's going to be drawing that tropical moisture in that poorly organized warm core low from the North Carolina coast up towards the New Jersey coastal waters. We could see how strong this short wave is, and to be frank, I was a little bit unimpressed at first. I was a little skeptical that it was going to be this strong, but there's the feature right up there. So you have your little short wave here that's lingering around with lingering below normal heights in the subtropical jet stream. So this moisture is going to hang around, potentially start to produce some warm core characteristics off the North Carolina coast. This feature here, which is very robust, dives down through the Great Lakes, should I say, and then swings back towards the St. Lawrence River Valley. It doesn't have to dig completely south into the Tennessee River Valley in this situation, but it does give you a warning sign, a pretty good indication of what I'm talking about in my concern for this summer. That if you get an upper level feature like this just far enough south, it could pull tropical systems and tropical moisture northward to produce very impressive heavy rainfall events. Now, in this scenario, because of the orientation of the trough with a slight positive tilt, it takes all that lifting and drives it up the coast very quickly. You can see somewhat of that circulation and somewhat of that structure here at 850 millibars. You can also see at 925 millibars. It's very weak, very disorganized, but you can see it even better in the precipitable water values. You can see this feature right here is clearly more enhanced than the rest of the moisture field out ahead of our cold front and the polar jet stream. So what this will signal is a very tight, heavy rainfall event on the New Jersey shore through New York City Metro, Long Island, into southern New England. However, if you are in eastern Pennsylvania, you're going to miss out the brunt of this. You'll get some scattered showers, but nowhere near as much rainfall as what the Jersey Shore is going to get. And then our cold front marches through quickly, and by the time we get to 8 a.m. on Sunday, a lot of that rainfall is driven off the coast. You can see how intense it is because of the enhanced lifting from frontogenesis. And you can see the dry air coming in behind that with clearing skies by the time we get to Sunday afternoon. And what that looks like in the model guidance, after some very beautiful weather through the rest of this week, here comes a heavy rainfall event, and there is our warm core right here. And that is why I'm expecting that we could see about 1/2 inch to 1.5 inch of rain from essentially the Delaware River on through Connecticut. A very intense, very short-lived, low-pressure system that, by the way, because of the cold front, is going to move very quickly and drive right out of here. So, very interesting scenario, and I don't think it's going to be the last time we're going to see it this summer. So with that, I am going to start taking your questions, and there are quite a few already. That's excellent. And of course, I will also check out YouTube and see what questions we have there as well once we get to that. So first of all, let's see here. Card, of course, has plenty of questions. How you doing out there? Lots of haze from the wildfire smoke this evening. Yep, that is exactly what this is. That is building in. Bet you there's some farmers and growers who would really like the smoke to keep up overnight temps. Oh, I could totally see that. If one just paid attention to sea surface temperatures, they would have been way off on the way the past La Nina acted. You know, that's an interesting point. The way that La Nina acted had a lot of characteristics like El Nino, and it produced a lot of unusual characteristics, no doubt. And part of that was due to the influence of the volcanic forcing. Now, that factor, I think, has faded away enough so that way I'm not too worried about it. And certainly by the time we get to the next cold season, it won't be too much of a factor because the influences are a little bit more spread out. It isn't as dynamic. This El Nino, I think, has the potential to surprise us quite a bit. I think it has the potential to be strong, but not be a typical strong El Nino. And the reason why I say that is that I'm keeping a very keen eye on what's happening in the stratosphere and the signals that we're seeing. And I'm keeping an eye on how the convection is evolving here. If I can find the right website. There we go. How that convection is developing here. The more that we see the convection firing around the date line, the stronger support we have of a trough on the East Coast, and the stronger potential you have of high latitude blocking as you move further on. We can still have high latitude blocking in the summer. It's just a different orientation. You don't want to take the same rules that you had with a negative NAO in the winter to what you have in the summer. Is two different type of scenarios. So your stratospheric anomaly discussion, there is a big pool of warm strat air right in the area south of the Aleutians. That's a sweet spot for troughs. Yeah, and the thing that's interesting is that in the data I was just showing back here we are, we supposedly kind of lose that a little bit. Now, what I'm curious about is that this keeps on happening once you get past 120 hours. But we also start to see a lot more below normal heights around the Hudson Bay. So this would support below normal heights here, above normal heights here. But remember, the wavelengths aren't the same as what you would expect in the winter. So you can still support a broad trough around the Aleutians, and then a broad ridge in the polar jet stream, and a broad trough over eastern North America. So very interesting pattern, definitely setting up, I think, as we move forward. Earth New School showing the 700 millibar, that 700 millibar still has a weak paperclip shaped polar vortex that has its base in the mid-Atlantic and northern Russia vortex. Let's take a look at that. Let's see here. 70 millibars. Okay. So we have a very broad, very weak circulation. Really, you have a couple different vortices here rotating around. I have to wonder whether or not that has to do with any of those cold pools and supporting some of that circulation and thermal gradient. Notice the overall theme of the pattern. Ridge, trough. Very much a signal from El Nino influence. So it looks like the El Nino influence is working up all the way up through the atmosphere. Very interesting to see that take place. What does it mean for us if El Nino does not have a distinct west or east base orientation? Great question. When you don't have a distinct orientation in your El Nino, you really, really need to keep an eye on the MJO and where that convection is firing. Okay? When you have a broad El Nino, in my opinion, you pretty much have a lot of wild cards showing up here. Because like when you're in east, when you have a lot of your warmest water in Nino 3 and 1.2, you know what to expect. Okay? You know that it's very difficult to have a high latitude blocking. You have a very progressive jet stream. You have a lot of Pacific systems coming into the west coast and marching across the country. When you have more of a west base, more towards the date line, you have a lot of convection on the date line, so you have a lot of enhancement around the Aleutians. You have more enhancement of a ridge on the west coast, trough over the east coast, and you increase your potential for cyclogenesis on the east coast. When you have a basin wide, you really need to watch how the convection is developing here. And you don't really have a chance to get locked into one theme or another, because you could have convection starting to fire here, and then it weakens and then starts to fire here. So you can kind of get a mix of all those patterns that El Nino can produce at the same time. So keeping an eye on the convection and understanding what that means in a 5 to 7 day lag is really, really important, because basically all the cards are on the table. Okay, everything is possible in that type of scenario. Do you think that there is potential for a feedback process that impacts thunderstorm development like last year? Well, it's a little too early to tell. I haven't seen a very strong signal in the mesoscale that would limit or enhance thunderstorm development. I thought we were starting to develop it in March and April, but it really hasn't been firing all that much since then. And no real strong signal has been showing up. I think that we're going to have to wait a little bit before we can answer that question. But in terms of the overall pattern itself, in terms of the cold stratospheric environment, it opens up the potential that any thunderstorm that does develop is going to be capable of reaching the heights of severe levels. So I would not be surprised if we have some thunderstorm events where you get one or two of these thunderstorms that really just maxes out in this type of environment. And we've seen that a lot in the spring as we head back towards the plains and the Tennessee River Valley, where these thunderstorms just blow up and they really maximize their potential. This weekend's scenario would be bad news in the fall with a strong tropical system in the same area being drawn up to our area. Yes, it would. It would certainly would be. So basically for AC this weekend, drive down on Friday is good. Drive back Sunday early afternoon is okay. Stay indoors Saturday night. I'll put it this way. Me and my wife were planning a movie weekend on Saturday or just stay indoors and probably keep on decorating and working on things in the house, because we're not planning to go out, after roughly 4 o'clock on Saturday. Just let it rain, stay indoors, talk to the guinea pig. That's about it. It's going to be one of those Saturdays where you're probably just going to want to stay indoors. Let's take a look and see what we got on YouTube. All right. Zaya says, and I am so bad with names. Honestly, I am. I am just horrendous at names. I love your new setup. Thank you. I feel like I'm engaging in a meteorology college course. Happy for you and the new establishment. I really appreciate it. Thank you very much. More interesting things on the way. Oh, and by the way, that reminds me, if you're interested in where I am getting my information, This is, let's see if I'm holding this up correctly. An Introduction to Dynamic Meteorology. All right, it is written by James R. Holton. You can get it from the American Meteorological Society, and I'm sure at any college library. This book was the one I got in college, and I am using the equations right up here. I don't know if you could see that. On page 3, basically 385 to 390, all those equations to create this diagram here. It is a great book. It's a good starter, I think, so that you can understand the equations and the mathematical values of how we get to what we get in terms of the precipitated water values, the tropical development. It's a great book, so definitely you want to check that out and read that. So it is, just to be sure you remember, An Introduction to Dynamic Meteorology, and probably caused me to lose some of my hair with all the equations I had to work on this thing, by James R. Holton, 3rd edition. I think they're probably up to the 4th or 5th edition by this point. It's been 20 years. But it's an excellent book to check out. Let's see. Very informative. I'm new to the lives, but I'll check out the lives from now on. Well, thank you, Jay Dice. I really appreciate it. Carol D. I'm not going to bother. All right. Could more tropical storms start to happen in May more than June? Great question. Okay. How do I want to answer this? All right. Let me first pull up the sea surface temperature anomalies. Now, for this year, we have a ton of warm water to deal with in the Atlantic. But we also have a lot of shear. Let me go back to 250 millibars. Heck, let's go down to 500 millibars. Okay, so you have plenty of warm water, but you also have this signal right here, which shows up even better at 250 millibars. Why is this important? Well, this feature acts like a machete to tropical systems. It just cuts its head right off. Tropical systems cannot form in this shear environment. So in May, in order to get a tropical system to develop, it has to develop along a frontal boundary or some sort of unique weakness in the atmosphere that allows for a feedback process. You're more likely to get a subtropical system. Now, could you start getting more in May than in June? I don't think so. I think in June you just have a more favorable environment overall compared to May, and then more so compared to July, and so on and so forth. But I think we're going to see more named May systems as subtropical storms. And I know some people like to have conspiracy theories about this, but the reason why we're seeing more subtropical storms is that we have a better understanding of the structures of these low pressure systems. I guarantee you we had plenty of these in the 80s and 90s, but we didn't have the data collection that we do now. I mean, in the 80s and 90s, you were waiting for a satellite every 30 minutes to kind of pass on through. Hopefully you get a good shot. Maybe you get an airplane or a ship that's passing by and you can get some additional information, right? Now you have drones that can fly into these things. You have satellites that go down to 1 kilometer, in view. And it's updated every 15 minutes or even less. So the environment is different. The ability to collect data is different. So we're seeing more of these subtropical storms because we have a better understanding of the structure that makes these systems. So with that said, I do think we're going to see more subtropical and maybe even tropical systems in May, but I think on average they'll more likely be in June and July and so on and so forth. Hi Steve, any thoughts on how the overall severe weather season has developed? Seems like it was earlier this year. What are your thoughts on severe potential this summer? Okay, so we certainly got off to a very impressive start, that is for sure, but it has gotten much quieter since then. The reason why is because of our trough orientation, and I could just use the wind pattern here. You can see our trough axis, for the most part, for much of late April and May, has been focused more, well, almost literally right over us in the Canadian Maritimes. And this is a predominantly northwesterly flow. It's usually a drier flow, and doesn't really open up the potential for severe thunderstorms. However, when we start to move into an MJO phase 7 and we start to get this trough axis more towards the Great Lakes, I think that opens up the potential of drawing air masses up from the Gulf of Mexico, and as a result, more tropical air and a higher potential for severe thunderstorms. With that said, in this environment, with this type of stratospheric environment in place, and with precipitable water values enhanced for a variety of reasons, if we get a severe weather event, I think that those storms will be dynamic. And they'll be capable of some very impressive heavy rainfall events. I wouldn't be surprised if we get some pretty good hail and tornado events as we move on through the summer. But a lot of it depends on the trough orientation. If it stays like this, we pretty much get a heavy rainfall event followed by a dry, cool weather pattern like we're having now. If it locks in more towards the Great Lakes and towards the Tennessee River Valley, we're going to be a lot more busy with severe thunderstorms. So I think we'll start to see a shift to that once we get the PDO into a positive state. So I'm thinking about the timing early to mid-July, somewhere in that ballpark. I don't want to say June because, I mean, it could happen in June, but that's a really rapid change. I'm not comfortable going with that just yet. I would need more observational support for that. But let's shoot for July. Let's see. 1 minute. Oh, there we are. Have you watched Twister? Yeah, I saw Twister. You don't want to bring meteorologists to those type of movies. I got thrown out because I'm like, that can't happen. That shouldn't happen. Me and a couple other fellow meteorologists, I was working for a company at the time, we went to that movie and, well, it just didn't go over well. You know, if the tornado is going right over you, there is nothing you can hold on to that's going to allow you to survive that. Will there be heat waves? Usually in the summer we'll at least have one or two. You know, I can't say we'll have no heat waves. That's like going into winter and saying we'll never have a cold snap. But I think this year is more likely to see less heat waves. But do be aware of high humidity. Okay? I'm very, very concerned about that, especially if we get that trough locked in around the Tennessee River Valley. I would not be surprised if we see a lot of days where we're 88, 89 with a dew point of 72. That soupy, ugly type of air mass. Not necessarily technically a heat wave, but it'll sure feel like one. How do we remove the shear? How much money do I need to lay down? I personally would like to keep as much shear as possible over the Atlantic because I don't need a tropical system. That is for sure. I'm ready for the summer because I can go to the beach and stuff. When do you think it will be 60s and 70s during the night? Typically what you want to do is wait until mid-June, usually mid-June. You'll start seeing that more and more. I mean, mornings aren't bad, but I like 70s in the morning. You would be alone in that, but that's okay. I would say definitely more like in mid-June. You should start seeing that more. I hope the summer is better than the winter. Well, I guess that depends on what you're looking for. Does humidity create strong to severe thunderstorms? The more moisture you have in the atmosphere, the better potential a thunderstorm has to grow. Okay, water vapor and thus humidity is essentially the fuel source for a thunderstorm. It's called latent heat energy. Okay, so when a thunderstorm grows up and blows up, it has latent heat release, right? So the more humidity you have in the atmosphere, the more fuel thunderstorms have and the stronger that they can get. It's very, very difficult, although not impossible, to get a severe thunderstorm in a dry environment. It is far more likely in a moist environment. However, there are different types of severe thunderstorms depending on the amount of moisture in the atmosphere. You can have some thunderstorms where you have a lot of moisture. It produces torrential downpours and downburst wind gusts where the rain-cooled air that's been lifted up crashes down to the surface like a rock. So it kind of depends on the evolution of that thunderstorm and the environment that it's in. I heard they make NASA recruits list errors in Armageddon. Perhaps Twister would be fun with meteorologist to. Oh my God, NASA's is going. Armageddon was a very, very funny movie. I guess you could call it emotional too. Had a couple of good songs though. I would not base it on science, but it was certainly entertaining. But I think that's the case with a lot of different movies, depending on whatever. Yeah. Well, of course, in their Sharknadoes, I literally got emails asking people whether or not it could actually happen. I'm like, sure. Shark just flying in the air eating people? Why not? Sure. Let's see. Do you recall the last time 850 millibar temperatures in mid-May were as cold as they are now for our area? I don't recall any. Let me think here. Honestly, probably the last strong El Nino event. But I do agree, it is pretty chilly. I definitely agree with that. It is definitely catching my eye as being a very chilly weather pattern this year for the start of summer. Personally, look, I know some of you guys like hot and humid summers, but for me personally, I am very, very much enjoying this weather as well as my electric bill. As the more I can keep the air conditioner off, the better, personally. So hopefully we can continue on with this cool stretch. I know some people are very much into the hot and humid summer. I feel like Twister is a fake movie. Yeah, I'd put Twister in the same ballpark as Jurassic Park. It's a fun movie. I just wouldn't base your thesis on it for science. I'll put it that way. What is the catalyst for thunderstorm sound strength, and how does thunder and lightning happen? Okay, well, let's see here. You know what? I'll draw it out in a second. This is a good chance for me to draw this out. Let's see here. Okay. So, I'm going to erase this masterpiece here. Hope you guys don't mind. Okay. Now, when thunderstorms develop, okay, there's our thunderstorm. You have moisture rapidly rising, okay? Now, as that moisture is rapidly rising, you get a lot of water vapor build up. And that H2O has a lot of charge to it. And that charge, the interaction of the charges, creates positive and negative and positive zones. And then you got some negative zones down here. Now, with all of this charging going on and a lot of rising air at the same time, you start to create electrical currents. Now, this develops because of the rapid rising in the air associated with the thunderstorm, which is what creates our charge mechanism. So what happens is that your lightning bolt starts at the surface, goes up to the cloud, and then back again. The initial rise from the surface is your start of your lightning bolt, and then what you see is basically the tracer back down. So you have an electrical current going up and down. Now that electrical current creates a whole lot of heat around it. And that heat is surrounded by much cooler air relatively in the thunderstorm, especially with rain-cooled air. So that interaction here leads to rapid movement of air. And so that rapid movement of air is what you call thunder. So lightning is the movement of charge, and thunder is the rapid movement of air as a result of the intense heat created by the electrical charge. So I think that answers that question pretty well. And I'll just take this back and make sure Susan has plenty of room. Is that good? Okay. So I hope that answered that question. Wow, we have had some great questions here tonight. And oh, by the way, the Mets are only down by 1 run. They might win this game. Maybe. I don't know. We'll see. We'll see what happens. But I hope that answers your question. And it's 8:46. So let's see what else do we have here in terms of questions. Pretty quiet right now. You know, when I'm thinking about baseball, I don't know, you guys tell me, especially, because I know some of you guys have different fan bases and whatnot. Do you think that using the pitch clock and making these pitchers throw faster is going to create A, more injuries, and B, poor pitching practices in terms of with them having to reset so quickly that they're overexerting themselves and they're having a more difficult time getting deeper into games, even more so, which can create more issues with bicep tendonitis and other types of injuries. I'm just curious to see what you guys think out there, because I don't know. I think this whole pitch clock thing is a bad thing, personally. Okay. Let's go back. Every so often, I like to throw in a little bit of baseball. Sometimes the way I see it is that sports radio people already always try to talk about the weather, especially when there's a rain delay or whatever, like as if they know what they're talking about. So I figure in a weather cast, I can talk about the sports, like as if I know what I'm talking about. Even though I only played football. Well, all right. I played baseball very poorly. And I played football even more poorly, but I went to all the practices. So there is that. But boy, oh boy, let's look at that dry air. You want to talk about dry air. Look at this. Look at these dew points. 18, 19, 21. We get enough clearing skies. These temperatures are going to plummet. These winds are light. This is going to be a very chilly night. I'm curious here. Let me pull up some data here. We'll pull up the HRR. Let's pull up the 2-meter temperature and see if this is updated. And by tomorrow morning, look at this. That's trouble up towards the Poconos and Catskills. 33, 32, 35. That is some chilly air. So hopefully that smoke causes this not to verify, but it certainly is supported by how low these dew points are. It definitely has the potential here of getting very chilly tonight. Yes and yes, and not a fan of the pitch clock or any of the other gimmicks. Agreed. What does the Western Pacific look like? Any tropical systems at all? Not anything that would impact our forecast right now. Typically during El Nino, the Eastern Pacific gets more active. The Western Pacific is a little bit less active, but the influence on the Western Pacific still has pretty significant storms. From what I found, less storms, but they're more intense, if that makes sense. But right now, there's nothing really that stands out. Let's see. Wow, some chilly temperatures. Well, it's 8:50. If you have any more questions, we'll take them. Other than that, I'll say about in a minute or so we'll shut down for the night. Before I start going on a rant, as the Mets did not get the guy in from second. Big surprise there. I don't know. I give up. What can you say? Last year was beautiful. This year, not so much. Okay, so we're going to end it here for tonight. Looks like we answered all the questions. I hope you guys enjoyed yourselves. Thank you for all the excellent questions. And, as we continue on through the summer, we'll keep an eye on the tropics and we'll keep an eye on the thunderstorm potential. And of course, we'll have updates tomorrow morning on the potential for the heavy rainfall event with videos right here, as we do every morning, Monday through Friday. Have a wonderful night, and as always, stay safe out there.